Hello, today I'll be solving a variety of center of mass problems, starting with finding the center of mass of the region bounded by f of x equals x minus x squared and g of x equals negative x. The first step in any center of mass problem is to use the first equation. Mass is the integral, and in this case it is from 0 to 2 because the region is bounded from 0 to 2 of f of x, which is x minus x squared, subtracted by g of x, which is negative x, dx. The first thing we're going to do is combine like terms. So the integral from 0 to 2 of 2x minus x squared dx. Then your next step is to find the integral of each of these things. So it would be the integral of 2x is x squared, and the integral of negative x squared is negative x cubed over 3 from 2 to 0. You plug in 2 wherever you see x, so you get 2 squared minus 2 cubed over 3, which becomes 4 minus 8 over 3. You don't need to worry about the 0 because once you plug it in, they would all cancel. So 4 minus 8 over 3, you can find the common denominator, so 12 over 3 minus 8 over 3, which leaves you to 4 over 3. This is your mass, or the area of the entire region. Your next step is to either find the moment of y or the moment of x. For this, I decided to do the moment of y next. So you keep the same integral from 0 to 2, and then you do f of x, which is x minus x squared, minus g of x, all multiplied by x. So your first step again, you would want to combine like terms, so you get the integral from 0 to 2 of 2x minus x squared, but this time it's all multiplied by x. So then you distribute this x, so you get the integral from 0 to 2 of 2x squared minus x cubed, and then you integrate. The integral of 2x squared is 2/3 x cubed, and integral of x cubed is 1/4 x to the 4th. And then you are from 0 to 2. You plug in 2 again, so you get 2 cubed is 8 times 2 is 16 over 3 minus 2 to the 4th, which is 16 over 4. And then you keep the 0 out. You can multiply both of these by 4 to get a common denominator. So then you get 64 over 12. And you should multiply this and this by 3, 48 over 12. And then you get 64 minus 48 all over 12. 16 over 12, which can be simplified to 4 over 3. When this is my. The next thing you want to do is move on to mx, which is half of the integral from 0 to 2 of f of x squared, which is x minus x squared squared, minus g of x squared, which is negative x squared, dx. The first thing you're going to do is simplify everything in the integral. So you do 1/2 times the integral of 0 to 2 of, you can do x minus x squared times x minus x squared minus, and this becomes x squared dx, all of this. Then you do FOIL, 1/2 the integral of 0 to 2 of x squared minus 2 x squared x cubed plus x to the fourth minus x squared dx. So then, simplifying this, you get 1/2 the integral of 0 to 2 of negative 2x cubed plus x to the fourth dx. Then you get 1/2, and then you integrate this, so you get negative 1/2 x to the fourth plus 1/5 x to the fifth, and then your limits of integration are 2 to 0. You plug in, you keep the 1/2 on the outside, then you plug in 2 wherever you have x. So 2 to the fourth is 16, so, and 16 over 2 is 8, so negative 8 plus 2 to the fifth, which is 32 over 5. And you can find common denominators here, so you do 1/2 times 40 over 5, negative 40 over 5, plus 32 over 5, and then you get 1/2 times negative 8 over 5, leading you to negative 8 over 10, which equals negative 4/5. After you find my and m of x, your last step is to do x bar and y bar. Yeah, x bar is moment y over the mass. So here we have my being 4/3 divided by the mass, which we got here is 4/3. So x bar equals 1. Then you want to do y bar. Which is the moment of x divided by the mass. So negative 4/5 divided by the mass is 4/3. So then you get negative 3/5. So last step is to just write your x bar to find the center of mass. Your x bar is 1 and your y bar is negative 3/5. So this would be the center of mass of the region bounded by f of x equals x minus x squared and g of x equals negative x between 0 and 2. This is center of mass, example 2, and today we'll be finding the center of mass of the region bounded by the x-axis and y equals 2 over x squared. So in this example, you only have an f of x, which is 2 over x squared, and you do not have a g of x. So wherever you see a g of x, you can plug that in as 0. So the first step is to find the area of the region. So this is just the integral from 1 to 2 of 2 over x squared dx. And another way to write this is the integral from 1 to 2 of 2x to the negative 2 dx. And then you can do power rule to find the integral. So you integrate this and you get negative 2x to the negative 1 from 2 to 1 dx. So then you plug this in. When you plug 2 in, so you can plug 2 in first, and then you subtract. When you plug in 1, you subtract that. So negative 2 times 1 to the negative 1. So this is basically negative 2 over 2, which is negative 1, subtracted by negative 2. So this is just 2 minus 1, which is 1. Next step is to find m of y, the moment of y, which is the integral from 1 to 2 of f of x, which is 2x to the negative 2, minus g of x, which is 0 in this case, multiplied by x. So all of this multiplied by x dx. Then you get the integral from 1 to 2 of 2x to the negative 1 dx. And then you can pull out the 2, So you get 2 integral 1 to 2 of x to the negative 1 dx. And then this is also the same as 2 times the integral of 1 to 2, 1 over x dx. And then the integral of 1 over x is ln x. So you have 2 times ln x from 2 to 1. So this is 2 ln 2 minus 2 ln 1. 2 ln 1 is just 0, so this becomes 2 ln 2, which is approximately 1.39. Next step is to go to your m of x. So we want to do 1/2 times the integral from 1 to 2 of f of x squared. So just 2 times x to the negative 2 squared dx. This is 1/2 times the integral from 1 to 2 of 4x to the negative 4 dx. And then you integrate. So 1/2 times negative 4/3 x to the negative 3 from 2 to 1. So 1/2, open brackets, 2 to the negative 3. Well, x to the negative 3 is the same as 4 times 3 times x cubed from 2 to 1. So then you can plug in 2. So you get 1/2 times negative 4 over 2 cubed is 8 times 3, which is 24, subtracted by negative 4 all over 1 cubed, so this is just 3. So then you simplify. 1/2 times the integral of negative 1 over 6 plus 4 over 3, which is the same as 8 over 6. And then you get 1/2 times 7 over 6, which is equal to 7 over 12, which is approximately 0.58. Now because your mass is 1, for your x bar and your y bar, you can just use what you got for the my and the mx. So x bar is my over mass, but since the mass equals 1, x bar in this case just equals my, which is approximately 1.39. And for your y bar, you can just use m of x because the mass once again is 1. So y bar equals 0.58. So your center of mass for this problem would be 1.39, 0.58.